Okay, so welcome to my introductory video about audit sampling. Okay, so what is audit sampling? Well, the best way to think about this is in terms of a population and a sample. So we may have an underlying population, which is, for example, all of the customers with account receivable balances. So imagine that's our population. Now, of course, it's too costly, too time consuming for an auditor to test every balance within the population. And so what auditors will do is select a sample from the population for testing. Okay, so the auditor selects a sample here, and then based on the results of the sample, the auditor will draw an inference about the population. Okay, so the idea here is that the sample should give the auditor some idea about how large the misstatements are within the population. So that's essentially what audit sampling is. Now let me turn to the seminar outline to explain to you what we're going to talk about in the seminar. In the objectives, there are 3 objectives. First of all, you should be able to explain some common audit deficiencies in sampling that have been found by PCAOB inspectors. I will cover that actually in this video. Secondly, how do you determine the correct sample size when using difference estimation and monetary unit sampling? I will talk in detail in this video about difference estimation, and I'll leave the monetary unit sampling to the actual seminar where we meet. And then the third objective is for you to understand how to evaluate your sampling results. In other words, how do you draw inferences about the population from your sample? So again, in this video, I'll cover that for the case of difference estimation, and then in the class, I'll go over monetary unit sampling. In terms of the reading, as always, you need to read the class questions on the seminar outline, view the video, which I'm currently creating. If you want to have a look at a textbook, particularly for the monetary unit sampling, because I'm not covering that in this video, if you'd like to find out more about MUS, read chapter 17 of the Ahrens, Elder, Beasley, and Hogan textbook. Okay. In addition, there's an auditing standard 2315, which I've put as optional reading. In the class, we'll go over 2 questions. The first question is difference estimation. And so 3 parts of this. First of all, I want you to tell me what the sample size should be. So how many customer accounts should the auditor seek to confirm? Then for part B, what should the auditor conclude about the client's recorded account receivable balance given these results in the auditor's sample? And then part C, what type of sampling risk does the auditor incur by making the conclusion that you arrived at in part B? Okay, so that's the first question for difference estimation. The second question is using monetary unit sampling. Okay, so again, you're going to calculate the correct sample size. Then you're going to calculate the upper misstatement bound and the lower misstatement bound. Then you're going to make your conclusion about whether the audited balances for account receivable are materially different from the client's recorded balances. And then you're going to tell me what kind of sampling risk does this conclusion incur. And then part D says, suppose that there weren't any misstatements found in the auditor's sample, what would the auditor then have concluded about the existence of a material misstatement? Okay, so monetary unit sampling I'll cover in a lot more detail in the class. Difference estimation I will talk about in this video so that you can make a crack on question 1 without doing any further reading. Okay, so those are the learning objectives for the class. So first of all, let's start with the definition of audit sampling. Audit sampling means the application of audit procedures to less than 100% of the items within an account balance. Okay, so in other words, you're not going to test everything within the population, you're selecting a sample. And the reason that auditors use sampling is to evaluate evidence about some characteristic of the item selected in order to form a conclusion about the population. This audit sampling can be used as tests of control or as substantive tests. In this particular seminar, I'm going to focus only on substantive testing, that is difference estimation and monetary unit sampling. If you're interested in attribute sampling, it's simply just like a special case of what we're talking about in the class, but you can have a look at tests of control and attribute sampling in the textbook. Okay, so auditors collect evidence on a sample basis because it would be much too costly for the auditor to test every transaction and an account balance. Okay, so this has created what some have called the expectations gap, right? Some people believe that the auditor's job is to check everything, okay? So that's good and bad from an auditor's perspective. It's bad in the sense that if subsequently a misstatement is found, the auditor gets the blame very often because people think, well, auditors should have checked everything. So if there is a misstatement, then it's the auditor's fault for not finding it. So that's the bad side of the expectations gap. But the good side of the expectations gap is that if employees have this incorrect perception, then they're less likely to engage in fraud. Right? So if you're an employee and you know that an auditor is coming in at the end of the year and you think incorrectly that they're going to check everything, then you're much less likely to engage in fraud. Okay, so it's kind of swings and roundabouts from this expectations gap. Now, what do we mean by a representative sample? Well, a sample is representative of the population if it's expected to have the same characteristics as the population. Okay, so you can see that here. We've got a population of individuals here, and if we select them at random, for example, we end up with this representative sample, where the sample looks on average the same as the population. So for example, if the population has an error rate of 1% for recorded sales, so suppose for example that recorded sales are overstated by 1%, then a representative sample would also on average be expected to have a 1% error rate, okay, because the fact that it's representative means that it's expected to be just like the population. Now, a random sample is likely to be representative, but the downside of random sampling is it's likely to be inefficient. Okay, so when you draw a sample at random, you're not imposing any criteria on how you select items for the sample. But that may not be the most efficient way to do sampling. It may be more efficient to focus, for example, on high-risk items or items that are more likely to be misstated. So for example, if a client has a very small number of large customers, but a large number of very small customers, it may be more efficient for the sample to be heavily weighted towards large customers. Okay, in other words, it wouldn't be efficient to just draw the customers at random, because then the auditor would be spending a lot of time looking at these small customers who are not material. And if what you're concerned about is the risk of overstated sales or overstated receivables, it's most likely to be the large accounts that contain those material misstatements. So you'd want to weight your sample towards the large customers and weight it less towards the smaller customers. And that's where monetary unit sampling comes in, because monetary unit sampling ensures that the auditor sample is biased towards larger items. Okay, and I'll explain more about that when we come to it in the PowerPoint slides. Now, this topic also is related to the earlier topic on audit risk. If you remember, there are three components to audit risk. You have inherent risk, control risk, and the auditor's planned detection risk. Now, there are actually two sources of detection risk. Okay, so that's why I'm going to talk about detection risk here, okay, because this is related to the issue of sampling. So imagine that an auditor fails to detect a material misstatement because in some way the audit was deficient. All right, so suppose, for example, that the auditor just failed to notice that there was a misstatement in the auditor's sample. Or suppose, for example, the auditor was trying to test for an overstatement of sales, but instead of testing for the occurrence of sales, it tested for the completeness of sales, right? Then that would be deficient because the audit objective is not being met. So when auditors do a bad job, essentially, this is known as a non-sampling risk. Okay, so any errors that occur because of deficiencies in the way the audit is performed are known as non-sampling errors. And the risk of a non-sampling error occurring is known as non-sampling risk. Okay, so you can think of non-sampling risk as the risk that the auditor messes up the audit. Okay. Now, another possibility is that the auditor fails to detect a material misstatement, even though the audit was done competently. Okay, so there's no problem with the audit itself, but the reason the auditor didn't detect the misstatement is because the audit was done on a sample basis. Okay, so the auditor may miss a material misstatement just because the auditor doesn't check everything. So this is known as a sampling error. Okay, so sampling errors occur because of the nature of sampling. The auditor chose the correct sampling method, applied it in the right way, the auditor interpreted the results correctly, but the auditor still failed to uncover the material misstatement because the auditor hasn't checked everything. Right, so that's what we mean by detection risk. You have two types of detection risk. First one is non-sampling risk, where the auditor messes up. And the second one is sampling risk, where the auditor hasn't messed up, but it's simply that the auditor hasn't checked everything. Okay, now I should also mention that these non-sampling risks, quite confusingly perhaps, would include the auditor messing up in terms of sampling. So if, for example, the auditor didn't use the correct sampling method, if, for example, the auditor sample was too small, or if the auditor interpreted the results incorrectly, that would be known as a non-sampling risk, even though it involved the auditor sample. Okay, so that's just a slight confusion in terminology there. The best way to think of non-sampling risks is that the auditor messes up, whereas a sampling risk occurs because of the nature of sampling, that the auditor hasn't messed up, it's just that the auditor's not checking everything. Okay, so what we're going to do in the remainder of the class is just assume that the auditor is competent, right, and not making any mistakes. So we're just going to focus on these sampling errors. And the risk of a sampling error occurring is known as sampling risk. Now, there are two types of sampling error. One is where the auditor rejects a true hypothesis. This is known as a type 1 error. And the second type of sampling error is a type 2 error. This is where the auditor does not reject a false hypothesis. So what do we mean here by true and false hypotheses? Okay, well, suppose, for example, that the client has said that sales for the year are $10 million, right? So that's the hypothesis the auditor wants to test. Suppose that the client is telling the truth. Indeed, sales are $10 million. If the auditor comes to the conclusion that the client has misstated sales, even though sales were not misstated, that is where the auditor is rejecting a true hypothesis. So this is a type 1 error. So in this case, a type 1 error means that the client's financial statements are correct, but the auditor incorrectly thinks that the client's financial statements are materially misstated. So that's a type 1. Type 2 is just the opposite way around. Right? So type 2 is where the client does misstate the financial statements, but the auditor incorrectly concludes that they're not misstated. Right? So a false hypothesis here, what this means is that the client's claim is false. If a client is claiming that sales are 10 million, it may be that actually they're only, say, 8 million. And the auditor's mistake here, the error, is that the auditor does not reject that. Right? So the auditor is failing to detect a material misstatement. So type 1 errors are costly because essentially it means that the auditor is saying to the client, I think your financial statements are wrong, and in fact they're not wrong. Okay, it's just the auditor hasn't checked everything. That's why the auditor's coming to the incorrect conclusion. Whereas a type 2 error is where the auditor goes to the client and says, I don't think there are any material misstatements, but in fact, there is a material misstatement. So these type 2 errors are particularly costly to the auditor because they can result in the auditor being sued, losing reputation, or being sanctioned by the PCAOB. Type 1 errors are also costly, but the costs are less, right? Here, with type 1 errors, the cost is that the auditor may upset the client and lose the client because they're telling the client, they think the client's financial statements are wrong, and in fact, they're not wrong. Okay, so these are two types of sampling errors, and we can quantify the risk of each of these two errors occurring. And that's the main advantage of using statistical methods. Auditors are not required under current auditing standards to use statistical methods, but the major advantage of using these methods is that the auditor can actually quantify the amount of sampling risk that the auditor is taking on. And I'll show you how to quantify sampling risk when we come to using difference estimation and monetary unit sampling. So that's the sampling errors and the risk of sampling errors occurring. Non-sampling risk, as I mentioned before, is where the auditor messes up. Okay, so the auditor fails to detect a material misstatement because the audit was deficient. Right? So the auditor just hasn't done a competent audit. So that's what a non-sampling error is, and the risk of that happening is non-sampling risk. Now, as I said before, sometimes these audit deficiencies are actually in the area of sampling, but they're still called non-sampling errors. Right? So in other words, the auditor has made some mistake or there's some deficiency in the audit in the area of sampling. For example, the auditor sample is too small, and that is a deficient audit, so it's called a non-sampling error, even though it relates to the way in which the auditor did the sampling. Okay, so let me give you some examples of non-sampling errors that actually involve the auditor's use of sampling. All right, so first one, auditor selecting sample sizes that are too small. This is a very common one. And the PCAOB saying to the audit firm, look, you should have chosen a bigger sample size. You were too lazy. You should have done more testing. Right? So that's the first one. The second one is auditors limiting the sample to certain parts of the population while ignoring that there could be a material misstatement in the remainder of the population. Right? So suppose, for example, the auditor says, well, you know, we've got all these sales transactions in the year, and we really want to spend most of our time looking at large ones because it's the large ones that are more likely to create a material misstatement. So we'll sample the sales transactions in excess of some cutoff, call it X dollars, but then the auditor forgets that they also need to do some testing on sales transactions that are below X dollars. Okay, so this is another common type of mistake that auditors make. And the third one is auditors incorrectly evaluating the results of the sampling tests. The most common example of this is where the auditor finds some misstatements in the sample, and then the auditor says, well, in the sample, these misstatements are not material. The auditor's forgotten that the auditor should form a conclusion about whether there's likely to be a material misstatement in the population, right? So when you evaluate your results, it's very important to project the results of your sample to the population, and this is where sometimes auditors go wrong. I'll talk more about this when we go through difference estimation. Okay, so here's some examples of those deficiencies. First one, the sample is too small. Here's an example from PwC's inspection report for 2005. The PCAOB said that in 4 audits, the firm tested a sample of subsequent cash receipts that were received in payment of accounts receivable, recorded as of a specified date, but in each case, the sample size was inadequate. Okay, so this is a very common type of deficiency noted by the PCAOB. Second one, auditors limiting their sample to a subset of the overall population. This is a quote here taken from the PCAOB summary of inspections from 2018. It said auditors limited their testing to revenue transactions exceeding a certain amount or transactions recorded near the year end without considering the need to test the remainder of the population. Okay, so it's fine to, you know, construct tests that are focused on these more risky transactions, right? These large transactions or transactions near the year end. But the point is you can't ignore all the others. You also have to do some testing to obtain assurance on the rest of the population. And then the third one is inappropriately evaluating the results. So here's an example from PwC's inspection report from 2004. It says the engagement team used non-statistical audit sampling in testing the valuation of inventory. Now, non-statistical sampling essentially means that the auditors did not use anything like difference estimation or monetary unit sampling. The auditors were just guessing, essentially, right, what their sample size should be. Anyway, the PCAOB went on to say the engagement team did not project a known misstatement, so misstatement in the sample, to the untested portion of the materials inventory balance. Right. So in other words, the auditors should have tried to evaluate what the misstatement was in the population instead of just relying on the misstatement that they found within their sample. And again, if you use statistical sampling methods, it's much less likely that you will make this mistake. Okay. So although auditors are allowed to use non-statistical methods, I wouldn't recommend them. Because you're likely to fall foul of what the PCAOB expects, right? So if you use statistical methods, you're really providing a lot more confidence to your own tests. All right, so let me get into some different methods that auditors can use when doing substantive testing. I'm going to focus on two of the most popular methods. The first one is difference estimation, and then during the seminar, I'll talk about monetary unit sampling as well, okay? So these audit deficiencies can be avoided, the deficiencies noted by the PCAOB, if the auditor uses statistical methods. So that's why I'm teaching you this, to get you into the habit of thinking like a statistician, because that's going to help you avoid getting criticized by the PCAOB, okay? So with difference estimation, the basic idea here is you use the error in your sample to estimate what the error is likely to be in the population. Okay, this is the simpler of the two methods. Difference estimation relies on random sampling, which may not be the most efficient way to collect your sample. So that will then take us to monetary unit sampling, because with monetary unit sampling, you're not doing random sampling. Instead, the likelihood of sampling a particular item is going to be greater if that item is a larger value. So the basic idea of monetary unit sampling is quite similar to difference estimation, as you'll see when we go through it. But the key difference is that items with larger dollar values are more likely to be sampled, right? So each item in the population doesn't have an equal chance of being sampled in monetary unit sampling. In difference estimation, it does, because with difference estimation, you just draw the sample at random. Okay, so what I'm going to do now is to first talk about the basic idea behind difference estimation, then we'll run through the steps, and then in class, I'll get you to tell me what you think the answer should be to question number 1. Okay, so the basic idea. First of all, you select a random sample. Then you calculate the differences between the audited values and the client's recorded values, right? So these differences are the errors that you find within your sample. Then you project to the population, right? You estimate the population error by multiplying the average error in the sample by the number of items in the population. So if I go back to here, right? Inappropriate evaluation of the results. This is what PwC failed to do in this audit. Right? They should have projected to the population, but they didn't do that. Right? So that's what we're going to do. We're going to estimate the population error by multiplying the average error in the sample by the number of items in the population. Then the next step, we're going to take account of sampling risk, right? And we're going to calculate what's called the upper confidence limit. The upper confidence limit is the estimated error in the population plus an allowance for sampling risk. Okay, so again, The reason why we have sampling risk is because the auditor is not testing everything, right? So we want to consider what's the risk that the auditor may draw the incorrect conclusion, right? Either making a type 1 error or a type 2 error. So that's why we're going to allow for sampling risk. Right, so that's the fourth part of the basic idea. And then if the upper confidence limit, if that is, if the estimated error in the population plus the allowance for sampling risk exceeds the auditor's desired materiality level, then the auditor can conclude that there is a material misstatement. If the upper confidence limit does not exceed the auditor's materiality level, then any misstatement is immaterial. So that's the basic intuition for what's going to happen as I work through this. So what I'm going to do is give you an example, right? I'll work through the steps so that you can see how to do the calculations. Right, so the first thing to do is to state the null hypothesis. And the null hypothesis is always that the client's recorded balance is correct. So for example, if a client has said that accounts receivables are 5 million, then that's our null hypothesis, that recorded receivables are in fact 5 million. That's what we're going to test. The second step is to determine the correct sample size. And the sample size is given by this formula here. By the way, you do not need to remember or memorize any of the formulas that I'm going to give you. Anything that you need would always be given to you in the question. Okay, so don't worry about memorizing anything. So what do these letters represent? Well, little n here, this is the required sample size. SD star, this is our preliminary estimate of the population standard deviation. ZA is the Z statistic. I'll explain what this is in a moment. The Z statistic corresponding to the acceptable risk of incorrect acceptance. All right. So if you remember, we talked about an auditor incorrectly accepting a false hypothesis. This was a type 2 error. Okay, so ARIA is the acceptable risk of a type 2 error occurring. ZR is the Z statistic corresponding to the acceptable risk of incorrect rejection. So this is the type 1 risk that we talked about, where the client's recorded balance is correct and the auditor incorrectly rejects it. TM is the auditor's tolerable misstatement. That's the amount of misstatement the auditor is willing to tolerate, beyond which the auditor will say, well, this is material, so I'm not going to tolerate it. And then E star, this is the estimated error in the population. This is a preliminary estimate of the error before the auditor's done any sampling. And the other one that I haven't got down here is big N. Big N here is just the population sample size. Okay, so this is the formula for calculating the sample size. And I'm not going to derive this formula for you, right? It's involves quite a bit of mathematics, but I'll give you the intuition for what this formula kind of represents, right? So if you think about, first of all, the standard deviation, right? The standard deviation captures how much variability there is in the population. Okay, so if, for example, you think, well, there could be a lot of small areas, there could be a lot of large errors in the population, so there's a high standard deviation, right? There's a high variance in the errors, then that means you're going to need a larger sample size, right? Which kind of makes intuitive sense, right? The more the variance in the errors, the larger the sample needs to be in order for you to obtain assurance. ZA and ZR, remember, these are corresponding to these two risks. So when these two risks are high, ZA is high and ZR is high, then the sample size has to be larger. And when the population size is larger, then the sample size is larger, right? So for example, if you have a company with 100 customers versus a company with 1 million customers, the company with 1 million customers is going to need a larger sample. Okay. So that's in terms of the numerator. Think about the denominator, TM. Well, TM is the auditor's threshold for accepting or tolerating a misstatement. In other words, this is the auditor's materiality threshold. The phrase used by the PCAOB is tolerable misstatement. So that's the one I'm using here. But you can think of this as the materiality threshold. So what this is saying is that if the auditor is willing to tolerate larger misstatements, right, the materiality threshold is higher, then the sample size can be smaller, which makes sense, right? If the materiality threshold is higher, that means the auditor is needing less assurance. Okay, so the sample size can be smaller. And then if the estimated error in the population is larger, E star is bigger, then the denominator here is smaller. That's going to make the sample size bigger. So that also makes intuitive sense. If you think that there's going to be a large error in the population, then you need to have a larger sample to try and estimate what that error is. If you think that any error in the population is likely to be very small, then you're likely to choose a smaller sample. So that's just intuitively, you know, what goes into the sample size. But anyway, this is the formula that you use. Okay, so you determine the sample size. Now you have to figure out what's going to go into the formula. What are the numbers that you're going to plug in here? So what I need to do is to explain ZA and ZR, first of all. Okay. So remember the ARIA, this is the acceptable risk of incorrect acceptance, right? So you've got a null hypothesis which is false, and the auditor incorrectly accepts it as being true. And this is known as a type 2 risk. Right? So for example, the client records an account receivable of $5 million. That amount is misstated, materially misstated, but the auditor incorrectly concludes that it's not materially misstated. So that would be a type 2 error. Now this type of risk is a one-tailed risk. Why is that? Well, the reason is because the auditor's incorrect conclusion can only go in one direction. Right? The auditor is concluding that the amount is correct and the auditor is wrong, but the auditor can only be wrong in one way. Right? Either the balance is overstated or it's understated. It can't be the case that the balance is both overstated and understated. Right? So this is known as a one-tailed risk. So when the auditor makes the mistake of accepting what the client has recorded, even though there's a material misstatement, that's a one-tailed risk. Now, the other type of risk, the sampling risk, is the risk of incorrect rejection. So this is where the hypothesis is true, but the auditor wrongly rejects it. So, for example, the client has recorded a receivable balance of $5 million. That is actually true, but the auditor incorrectly concludes that there is a material misstatement. Okay, so this is the type 1 risk that I talked about before. Now this type 1 risk is two-tailed because the auditor's incorrect conclusion can go in two directions, right? So remember, in this case, the balance is correctly stated by the client, but the auditor is making a mistake, right? So the auditor's mistake can go in either direction. Either the auditor incorrectly concludes it's overstated, or the auditor incorrectly concludes that it's understated. So this is what is known as a two-tailed risk. Okay. Now you may be wondering, why am I emphasizing one-tailed and two-tailed? Well, the reason is because it's going to affect the Z values that we put into this formula. Okay. All right, so before I explain those Z values, I first need to remind you about the standard normal distribution. Hopefully you've all seen this at some point, maybe in high school. So let me just briefly remind you of the standard normal distribution, sometimes known as the bell curve. Okay. So a standard normal distribution is for a variable that has a mean of 0 and a standard deviation equal to 1. Right. So the mean is 0, right? Median and mode are also equal to 0. And basically what this distribution shows us is possible values of this variable and the likelihood of observing those values. So the likelihood of observing a value of x, which is greater than 0 when the average value of x is 0, is going to be 50%, right? So to the right of this vertical line here, if you add up all of these percentages to the right, that comes to 50%. And similarly to the left, all of these percentages add up to 50%. So the probability that X is less than 0 when the average value of X is equal to 0 is going to be 50%. Now we can calculate for any given value of X what the probability is, right? So for example, the probability that X is less than -3 is going to be 0.1%. The probability that X is less than -2.5 is going to be 0.1% plus 0.5%, etc. Okay. Now, if we have a two-tailed risk, so if we are thinking, for example, what's the probability that X is either less than -3 or greater than +3, those two probabilities are going to be 0.1% here plus 0.1% here. So when you have a two-tailed risk, you're adding up the risks from both the left and the right of the distribution, whereas when you have just a one-tailed risk, you're only focusing on one side of the distribution. Okay, these are the z-score values here, or I was calling it X, but you can also think of it as Z, right? So these are the Z's that correspond to these different probabilities. And here down here you have the cumulative percentage. So as I say, the probability that Z is less than -3 is 0.1%, and then it increases, the probability increases as you increase the value of Z. All right, so that's just a brief reminder of the standard normal distribution. Hopefully you've all come across this bell curve idea before. Okay, so what you can do then is to map that curve into the following table. Okay, so you can calculate what the risks are or what the probabilities are according to whether we're using a one-tailed or a two-tailed test. Okay, so remember the risk of incorrect acceptance is one-tailed and the risk of incorrect rejection is two-tailed. Okay, so if we're talking about a 99% confidence level, when it's a two-tailed risk, right, then we're going to be splitting this 1% in half, right? So we're going to have half down here and half up here, right? So we're splitting it in half, and so that's going to increase the value of our Z statistic. So that's going to be the equivalent to the case where we have a one-tailed risk, which is equal to 0.5%. Right? So these two-tailed risks are basically equivalent to one-tailed risk, which is half the value. All right? So when the risk of incorrect acceptance is 0.5%, or when the risk of incorrect rejection is 1%, this corresponds to a Z statistic of 2.58. Right? So if I go back to here, that is about there, right? 2.58, that's 0.1%, and then 0.4% takes us to about there. Okay. So anyway, of course, you don't need to memorize all of that. Any question that you were given, you'll be given this table here so that you can read off the Z statistics. But it is important that you remember the difference between these one-tailed and two-tailed risks. Okay, the risk of incorrect acceptance is one-tailed because the auditor can only make this mistake in one direction, but the risk of incorrect rejection can go in two different ways, so this is a two-tailed risk. So the confidence coefficients are obtained from the table on the previous slide. So for example, if the auditor chooses a risk of incorrect acceptance of 10%, then that's going to give a ZA of 1.28. Right? So here, risk of incorrect acceptance is 10%, the Z statistic is 1.28. Conversely, if the auditor chooses a risk of incorrect rejection of 25%, that gives us a Z statistic of 1.15. Right? Or in other words, here, the risk of incorrect rejection is 25%, so the Z statistic is 1.15. And it's totally up to the auditor what they choose as these two risks, right? It depends on how much risk the auditor wants to undergo, right? Remember, the risk of incorrect acceptance, the risk here is that you accept a balance as not being materially misstated when it is. So, this is the risk that, you might end up being sued or criticized on the television news or punished by the PCAOB, right? This is this risk. And then the risk of offending the client by telling them that their balance is wrong when in fact it's not wrong, that's this risk here. Okay, so the auditor just chooses these risks based on how risk averse the auditor is and what kind of client the auditor is auditing. Okay, so that's where the Z statistics come from. The next thing to do is to estimate the population standard deviation, SD star. So you can estimate that by using a preliminary sample, or if you've audited the client in the past, you can look back to the previous year and look at what the standard deviation was. Okay. The auditor estimates the population error. Okay, again, this can be estimated using a preliminary sample or using past audits. And the auditor chooses a tolerable materiality level. Right? In other words, what's the largest dollar error that you would accept and not regard it as material? Okay, beyond that threshold, you would regard the misstatement as being material. Okay, so you've got all these numbers now. And remember, the reason why you are assembling these numbers is you're going to plug them into this formula to obtain the optimal sample size. Okay, so once you've got all these numbers, you plug that in and calculate what the sample size should be. Okay, and in the question, if you look at question 1, all of these numbers are given to you, right? You're told what the risk of incorrect acceptance is, the risk of incorrect rejection. You're told what SD star is, what E star is, what TM is, and the population size. So you can just plug those numbers into the formula to obtain the sample size. Okay, once you've got the sample, then the next thing to do is to actually test the items in your sample to see whether there are any errors. And if there are errors, then you're going to add those errors up, right? So that you come up with an overall sample error. So these errors I've labeled with the letter E. I've called this an individual difference, right? Because this is a difference between the client's recorded value and the audited value, right? The value that the auditor determined it should be. Okay, so this individual difference is an error. Then you basically add up all of these errors within your sample, right? So sum of E is the sum of all of your errors. Some of these errors may be negative, some of them may be positive, right? Because you might find some items that are overstated, some that are understated. So when you add those up, they will offset each other. Then having done that, you calculate the average error in your sample. Right, so E bar here stands for my average error. That's the sum of the errors in the sample divided by the sample size. And then you project to the population, right? Again, if I run back to here, right, this is what PwC failed to do. They did not project the known misstatement to the untested portion of the balance, right? So that's what you have to do here in step 5. Right, you estimate the total error in the population, and the population I'm denoting here with capitals. So E bar is the estimated error in the population, which is the number of items in the population multiplied by the average error in the sample. Okay, so then you've got an estimate for the error in the population. Then the next thing to do is to consider sampling risk. But before you do that, it's worth just taking a note of the sign of E bar, all right? Because that's telling you whether the client's recorded value is overstated or understated. So if E bar is negative, that means the client's recorded value is more likely to be understated than overstated, okay? In other words, within your sample, you find that on average, the errors are negative, right? That is, the recorded value is less than the audited value. And conversely, if E bar is positive, that means that it's most likely that the client's recorded value is overstated rather than understated. that is that the recorded value is greater than the audited value. Right? All right, so make a note, a mental note when you do the calculation of which direction this is going in. Is it overstatement or is it an understatement? Okay, after doing that, what you need to do is to take account of sampling risk. And so the reason you do that is that you incur sampling risk. Remember, there's two types of sampling risk you're incurring. There's a type 1 and type 2 risk. And so the risk is that you make the wrong conclusion. Right? In other words, the estimated error for the population may not equal the actual population error, right? Because it could be you're rejecting a false hypothesis, or it could be that you're accepting a false hypothesis, or it could be that you're rejecting a true hypothesis, right? So you're incurring this sampling risk because you haven't sampled the entire population. So to quantify this sampling risk, you have to compute what's known as the precision interval, right? CPI stands for the computed precision interval, right? So how do you do that? Well, the formula is here, right? The computed precision interval is equal to the population size times ZA, right? This is your Z corresponding to the type 2 risk, risk of incorrect acceptance, multiplied by the standard deviation in your sample, divided by the square root of your sample size, multiplied by the square root of n minus n, this is the population size minus the sample size, divided by population size. Okay, again, I'm not going to derive this formula, but this is just basically a formula that is used to calculate sampling risk. What's the standard deviation? Well, you can use the following formula to calculate the standard deviation for the errors in your sample. Okay, so you take each error, call it EJ, you square the error, you add up the sum of the squared errors, that's the sum of E squared, then you subtract n times E bar squared, divide by n minus 1, that gives you the variance, then take the square root to get the standard deviation. Okay, so again, this formula is provided for you, right? You just have to plug the errors in your sample into this formula to calculate what the standard deviation is. Step 7 is to then calculate the upper and lower confidence limits for the population error. So what's the upper confidence limit? Well, it's the expected error in the population plus this allowance for sampling risk, right? So this allowance for sampling risk is because you are not testing everything in the population. So you need to kind of be conservative and add on an extra amount to reflect the highest likely error in the population, which is the upper confidence limit, right? So the upper confidence limit is just like a confidence interval. If you've done that in statistics before, it basically tells you what's the largest likely value for a given confidence level. Okay, LCL is just the opposite. This is the lowest likely error in the population. LCL is generally not of interest, right? Because as auditors, you're concerned about the largest likely error rather than the smallest likely error. But anyway, this is just the other side of the confidence interval, right? This is the expected error in the population minus the allowance of sampling risk, right? So this becomes relevant if E bar is negative, right? Then you are concerned with the largest likely negative misstatement. But if you're dealing with overstatements, then it's the upper confidence limit, right? The largest likely overstatement. Okay, so those are the UCL and LCL. And then the final step, and you know, this is kind of crucial. Once you've done all the calculations, you know, make sure you make the right conclusion. Right? You don't want to do all your tests and calculations and do all that work and then arrive at the wrong conclusion. Okay, so how do you arrive at the conclusion? Well, first of all, it's worth noting whether the error is expected to be positive or negative. Right? This is what I mentioned before. So if E bar is positive, this means that the population error is expected to be positive. That is, the balance is overstated. If E bar is negative, that means that the balance is likely to be understated. Okay. So what you need to do is to compare the upper confidence limit and the lower confidence limit with your tolerable materiality threshold. So if the balance is overstated, then you're going to compare the upper confidence limit with the auditor's tolerable misstatement threshold. In other words, if you think the highest likely error within the population allowing for sampling risk is greater than your materiality threshold, then you will conclude that it is materially overstated. Okay. Now the opposite is true in the case of understatements, right? The only thing with understatements is you have to take the absolute value of the lower confidence limit. Because remember, the lower confidence limit is E bar, which is negative here, right? Because the balance is being understated. So you want to take the absolute value of that, this negative number minus sampling risk, to the absolute value and compare that to the auditor's tolerable materiality threshold. Okay, so if there's an understatement and this understatement is larger than what the auditor is willing to tolerate, the auditor will conclude it's materially understated. Okay, so in these two cases, the auditor is rejecting the null hypothesis. So the risk that the auditor is incurring here is the risk of incorrect rejection. That is the type 1 risk that we talked about before. Okay, now if the upper confidence limit is less than the materiality threshold and the errors are positive on average, then the auditor can say, well, it's not materially overstated. And similarly, if the errors are negative, but the lower confidence limit in absolute terms is smaller than the materiality threshold, again, that's not a material misstatement. So you do not reject the null. So in these two cases, the risk that you're taking is the risk of incorrectly accepting the null hypothesis. Right? In other words, the null may be false, but you're concluding that it's not false. Okay, so those are the risks you incur in making this conclusion. Okay, so I've basically run through how you do the calculations for difference estimation. So what we're going to do in class is go through question 1. First of all, determine the sample size, right, using that formula that I showed you. Then I've said that with your sample, you find that there are 8 customers that have misstatements. And so what you're going to do is calculate the average error in your sample. Then you're going to project that to the population. Then you're going to calculate sampling risk. Then you're going to calculate the upper and lower confidence limits, and then make a conclusion, right, about whether the client's recorded balance is materially overstated, materially understated, or not materially misstated. Okay, so that's the second part. And then the third part is what type of sampling risk do you incur by making this conclusion? Okay, so that's difference estimation. We'll work through question 1 first, and then after doing that, I'll show you how to do monetary unit sampling, and we'll work through question 2. In advance of the class, I'd advise you to have a look at the PowerPoint slides for monetary unit sampling, because that will give you a step-by-step approach to see how to do question 2. All right, that's where I'm ending this video. Thank you for listening.